Hey everyone, welcome back to MLworks. In today's video, we'll be discussing the implementation of machine learning models with Metaflow backend. And in the previous video, I have explained how to set up Metaflow locally with Minikube. And I would recommend you to watch that video such that you can complete this exercise as well with machine learning models. Okay, so what we'll do right next, we'll be running multiple machine learning models one after another, and we'll check the performance. And then what we'll do is we'll be running them parallelly simultaneously with Metaflow and see the results. Okay, so it's quite a pretty simple exercise what we are going to do today. Okay, so with that, what I'll do is, so you are able to see the screen right now. So it is the Metaflow UI which is running on localhost 3000, and we are seeing all the different flows that have been executed till date. Okay, so what I'll do next is I'll go to VS Code, and so I'm under the folder ML Metaflows, and I'm talking about RandomForest machine learning model. So here first we import Metaflow. From that specific package, we'll be importing flow spec to create Metaflow flow, and then we'll use step to create turning our function, Python function, into Metaflow specific step function. And then we'll also take in parameters. So as we are aware, like all the machine learning models have some hyperparameters that we can tune. So we'll use this specific parameter module from Metaflow to handle or manage such hyperparameters. Okay, and it is declared at the top of the class of the RandomForest flow. So this is the flow name. RandomForest flow is the flow name. Now, so RandomForest has certain parameters like max depth, seed, n estimator, minimum samples, and k-fold k. Okay, this is for cross validation. Okay, so these are the parameters. We declare it like this. By default, value has none for max depth, seed has 11, default 10 estimators, and in minimum sample is 2, and k is equal to 5. Now this is the class. Now we start off with the step functions, or turning our Python into Metaflow function using the step decorator. So we give the name start, okay, definition def start and self, and we import the data set. Okay, so this is the first flow or first step function that will get executed when you are running the flow. So it will load the data set, which is iris data set, and we'll take our self.x and self.y, which is our features and labels, and then we'll pass on this, connect this to next function, which is train_rf, which is RandomForest. So in this function, what we do is we import the package where we take in RandomForest classifier and cross validation score module, such that this will ensure that we run this specific model across different set of features and labels while we are iterating through like k-fold times, and then we'll get the best model out of it. Okay, so this is where we declare our classifier and we pass in our parameters here, and then we have our cross validation score getting generated here, and then we connect this train_rf with self.end, which is nothing but another step function. Now what we'll do, right? So here in the step not the step. So in the end function, what we do is we calculate the mean score and standard deviation of the score, and we'll just print it. Okay, so this is the whole machine learning model that will run, which will train a model and give the score of in min and standard deviation of it. So let me just run this. So right now I want to go back to here. So these are the 5 flows, and this is the timing. Okay, now I'll be running this one, Python, which is RandomForest, and then metadata service, and then I'll be running run. So this should execute. So this created a run ID 6. Okay, so if you see previously we had run ID 5 till 5 we had. Now it is random forest flow. It got executed at random forest accuracy of 96% plus or minus 3.266. Okay, so this is nothing but if I go here, okay, this is the message, and here I am taking in the mean accuracy, okay, and this is I am taking in standard deviation plus or minus, okay, and this plus or minus is nothing but the specific symbol that we see here. Okay, now this is with respect to random forest. Now this is similarly what we can do is we can go to XGBoost and we'll take in the same set of parameters, not the same set of parameters, I mean same set of modules that are required for running the XGBoost as well. Set of parameters that are required by the XGBoost model, which is random state, n estimators, eval metric, and k-fold. And again we have step function getting created using step decorator. And here we import the data set again and connect it to the train function here. And here you will see we are loading our XGBoost classifier, and again we are importing cross-val score, and we are training the model here. Okay, once the training is done, so what we'll do is we'll connect it to the self.end, which is the next function, and here we'll be again getting our mean score, mean accuracy score, and standard deviation of the accuracy. Okay, so we'll do that here. This is similar to random forest as well, nothing has changed. Okay, so let me run this one. So I'll just go here, XGBoost dot, okay, so this is run ID 7. I'll go here, so XGBoost, that is that gradient boosted tree flow, and I'll go inside and I'll see what is the time taken for each step. Those things we can understand here, which is quite simpler to understand. Okay, there's nothing much present here. So this is with respect to XGBoost. Now these two models executed sequentially one after another. Now what I want to do is I want to run these models in parallel such that I can decide, right, like which model performs better. And I'll be doing that with the help of something called as branch, okay, which is one of the module or a function in Metaflow. What it will do is it will try to run two algorithms in parallel and connect them at the end, join them, okay, and get the results, give the results. Okay, let's understand that here. So this is the parallel underscore branch, branch, and we here import the same set of modules, flow spec and step and parameter. We create our class parallel trees flow and inherit the flow spec to create Metaflow flow. And then again we define the parameters for the different models we have. Okay, for max depth for random forest tree, and then eval metric or n estimators for both, right? We have it for random forest, also for XGBoost. And what is the loss, right? What is the loss metric here? So we have m log loss. So these are the parameters which are declared at the top of the class. Next is start function, which will take in the data set and connect it to two different step functions. One is random forest function, next is XGBoost function. So these two will get triggered once this is executed. Okay, this is our self.next. So in these two functions, what we do is, which we saw earlier, one will train the random forest classifier, the other will train the XGBoost classifier and give us the score, okay, for both here and here. Now what we do is, so this is calling the same function. Both of them are calling the same function. Random forest is calling self.score and XGBoost is calling the same self.score in the next step. So it will get joined here. Okay, so we take in the parameters like modeling underscore task. Now this is nothing but this is just referring to the output from this specific function, and this specific function. So what we do, we iterate through these modeling task, which is for model in modeling task, and then we get the model.model name, okay, and then we get the model score, and if you see here we have declared here model name, that's what. So we have here model name for random forest. So we fetch those specific parameters from each of those functions and get the mean and standard deviation score, and then send it to the next function, which is self.end. Next, as expected, it will iterate through the self.scores and we'll get the name, mean and standard deviation for that specific machine learning model. Okay, so let me run this also once. If I go here, parallel branch.py, and this is metadata service.run. So this is creating another bug, run ID 8, and if you see here, I'll just go here and it is running. So you'll notice, so these two models got executed almost at the same time, actually both got executed. Okay, so then we got a score and then end function was there. So if you see here, this is the score for RandomForest, this is the for XGBoost, and done. Okay, so what I wanted to show, right, since we are here, I'll just show the card. Okay, the card won't work because I have to mention card somewhere here. So let me share it here, card. I'll import card here also. This is for understanding the DAG, right? What we'll do is, let me run it again and we'll look at the DAG next. So I'll just do card server. Now I'll go to this specific localhost. So it's not coming up. Maybe what I have to do is, okay, I executed this one XGBoost. It's not XGBoost. I have to run parallel this one, parallel branch, right? Yeah. So let me refresh it again. Maybe I have to do it again. Let me run this one first. So run ID 10, and this is the task is getting completed almost. Okay, so we have our task is completed. Now we'll do card server. Okay, yeah. So you will see right here. So this was the run ID 10, and what is the score we are looking at, because if you see, right, I kept the card for score. So step function score is getting presented here. If I given card for everything, then I would have seen that step here. This is the card, and then it talks about all the information with respect to the flow parameter, and this is the DAG for this, and this is the score for these two artifacts, which is mean and standard deviation. This is the mean, this is the standard deviation, this is the mean, and this is the standard deviation for XGBoost. This is for RandomForest, and this is what the DAG looks like. Okay. So what we have done till now is we ran one specific model individually, RandomForest, then we executed XGBoost, and then we parallelly executed these two models, okay, and then got the score, and we looked at the card or DAG of this specific task as well. So with that, I'll be concluding this video for machine learning model, and what we'll do, right, we'll understand certain more Metaflow flows with respect to cross-validation, k-fold, and other techniques like for other models like deep learning models. Okay, we'll discuss that in the next video. Thank you for watching.